Okay, so I'm looking at problem 3 from homework 4, which involves the function f of x equals square root of x. So we're asked to first find a linear approximation to this function near the point x equals 4 to approximate the value of square root of 4.1. So to find a linear approximation, we need two things: a point on the line and the slope. So we know that the slope comes from the derivative of this function at the point. So what point are we interested in? X equals 4. So at x equals 4, we have that f of x is equal to square root 4, which is equal to 2. So 4, 2 is our point. And then we find the derivative of the function f prime of x is 1/2 x to the negative 1/2. And at this point of interest, 4, 2, we have that the slope of the tangent line is going to be f prime of 4, which is 1/2 times 1 over square root 4, which gives us 1/4. So our tangent line is going to be given by L equals x0, which is 4, or sorry, y0, 2, plus 1/4 x minus x0, which is 4. So we get this, and if we want to expand this out, we'll get 2 plus 1/4 x minus 1, which is 1/4 x plus 1. So that is the linear approximation to this function. And if we want to estimate square root 4.1 using this, then we would plug 4.1 into this equation here. It's approximately equal to 2 plus 1/4 4.1 minus 4, which is 2 plus 1 divided by 40, and this works out to be 2.025. Now, the true value of square root 4.1 is approximately equal to 2.0248456. So I've truncated the decimal, obviously, that's why I have an approximately here, but this is the number that your calculator will spit out. And so we can see that the linear approximation is an overestimate. Right here we have 2.025, here we have 2.024, and this is because f of x equals square root of x is a concave down function. Okay, so that's the linear approximation. Now the question is, can we do better by trying to do a quadratic approximation? So there's a slight trick here. So we want to find a, b, c, so that g of x, which equals, let's see, what order did I put those in? Ax squared plus bx plus c is the quadratic approximation to f of x. So the way you would do this is you would take the derivative of g of x take the derivatives of f of x, then take the second derivatives, set them all equal to each other. That would give you a system of 3 equations for 3 unknowns, which you could then solve. But it is a little messy, so there is a slight trick that we can use, and that is the following. First, we're going to find a tilde, b tilde, and c tilde, so that g tilde of x, which equals c tilde plus b tilde x minus 4 plus a tilde x minus 4 squared, is a quadratic approximation. And so you'll notice if you expand this all out, it's just going to be another quadratic function, and the constants in this quadratic function will tell us what the constants in this one should be. However, it's a little bit easier to do that with this one, since we're interested in matching derivatives at the point x equals 4. When we plug in x equals 4, there will be some cancellations in this g tilde equation, and that will make our lives a bit easier when solving the equations. So let's see how this works. So we have that f of x is equal to square root of x. F prime of x, by the power rule, is 1/2 x, and f double prime of x is equal to negative 1/4 x to the negative 3/2. Now if we plug in x equals 4, we have f of 4 equals 2, f prime of 4 equals 1/4, and f double prime of 4 will be equal to, let's see, negative 1/32 it looks like, because we have 1 over square root 4 is 2, cubed gives us 8, then times 1/4. So we have 1/8 times 1/4, which is 1/32. So then let's compare to g tilde of x. So g tilde of x is equal to this thing up here. G tilde prime of x, if we use the chain rule, the c tilde is just a constant, so that gives us a 0. The derivative of this term gives us b tilde plus 2, apply chain rule to this piece, 2a tilde times x minus 4. So we get this, and then we can calculate g double prime tilde of x is equal to 2a tilde. So now that we have this, we can plug in 4 everywhere, and you'll see that there's a lot of cancellation. So g tilde of 4 is just c tilde, g prime tilde of 4 is going to be b tilde, and g double prime tilde of 4, well, in this case, we just have this equal to 2a tilde, so we have this. Right, there's no x here, so it doesn't matter that we're plugging in 4. This is always the derivative. So now let's compare these equations. So to match derivatives of f and g, we have f of 4 equals g tilde. G tilde of 4 implies that c tilde should be equal to 2. F prime of 4 equals g tilde prime of 4 implies that b tilde should be equal to 1/4. And lastly, f double prime of 4 equals g tilde double prime of 4. In this case, we have to divide by 2 to solve for the a tilde, so we get that a tilde is equal to negative 1/64. Alright, so that means that g tilde of x, we now know all the constants that were in it. It's just equal to 2 plus 1/4 x minus 4 minus 1 over 64 x minus 4 squared. And the interesting thing here is if we go back to our answer to the earlier parts, this was our, let's see, you can see that. This was our linear approximation equation here. And you can see that it actually looks a lot like our quadratic approximation for the first two terms, but now we have an extra term with the squared in it. So now, this was all to find this function g tilde. Now we want to find the original a, b, c in the function g of x. But all we have to do in order to accomplish that is just to expand this polynomial and see how the coefficients match up. So if we expand this, we'll get 2 plus 1/4 x minus 1 minus 1 over 64 x squared plus, I believe, 1 over 8x, then minus 1 over 4. And if you simplify this, it looks like we get negative 1 over 64 x squared plus 3/8 x plus 3/4. So this implies a should be equal to negative 1 over 64, b is equal to 3 over 8, and c is equal to 3 over 4. So we found our equation g of x just by plugging these things in up here. G of x is negative 1 over 64 x squared plus 3/8 x plus 3/4. This is our quadratic approximation. And so if we use this to estimate the square root 4.1, then we'll get square root 4.1 is approximately equal to 2.0248437. And so if you compare that to this thing here, you see that we did a lot better than with just our linear approximation, right? We now matched the first 4 decimal places rather than just the first 2, or sorry, first 5 decimal places rather than the first 2. So the quadratic approximation did much better. If we wanted an even better approximation, you could do an approximation with a cubic polynomial, and you'd follow a similar procedure. You'd have the first, second, third function values, first derivative, second derivative, and third derivative all match, and so on. So this is a method known as Taylor approximation. It's really useful, but it's really a topic for Math 112L, so we won't pursue it any further in this course. But I just wanted to give you a brief preview of what this is like.